ladies and gentlemen, welcome to 8.4 Logarithmic Functions Part 2. Part 1 apparently had a copyright infringement. Try to mix in a funny video for you. YouTube didn't like it, so here we go. Let's try this again. Exponential growth and exponential decay. Tell which one is which. This will be decay because of the negative exponent. So this will end up being decay. Okay. In case you're wondering, think of E as 2.43 or 2.77, something along those lines. If I actually apply that negative exponent, right, this is kind of what you're looking at. Okay, and that's obviously smaller than 1. 1 over 2.2 is like a half, so that's going to be decay. This has a positive exponent. And this would be growth. If you're not sure, go ahead and plug those in on your graphing calculator and see which way they go. You know, for example, if we take a look at just the first one, you know, I'll let you do the second one on your own. It's second natural log, and that's the negative 7x. If I graph that, clearly it's going to be decay. If I zoom in a little bit better, you get a better look at it. This is decay here. Okay. So I'm going to zoom standard just to get that back to normal, close this out, and let's move into what we're doing today. So, how do we evaluate logarithmic functions and graph logarithmic functions? What is a logarithm? Okay, so really this is what you want to have memorized. Notice the base b is your base here, and it's raised to the x equals y. Now, so if we rewrite the following 3 in logarithms in exponential form, so we don't have log, the base is 2, so it's going to be 2 to the 5th equals 32. Over here, anything to the 0 power equals 1, 10 to the 0. And over here we have 1/5 to the negative 2nd equals 25, which is definitely true, because the negative flips this, makes it 5 squared. All right, next 3 here, from 4 to 6, we're now going to write them back in log form. Your base is your base, so we go log. Base is 11 of 121 equals 2. Over in number 5, the base is 2, so log base 2 of 32 will equal 5. And then the last one, log base 3 of 1/9 equals negative 2. And there, that would take care of 4, 5, and 6. So, let's keep rolling along. Use that knowledge with 7 through 15. 10 is the only one that we're going to end up doing on calculator, because you actually can't do that one by hand, and I'll kind of set that up so you see why that is. But think of this as equaling x. So we're going to have 2 to the x equals 32. Right? At this point, I'm going to rewrite 32 as 2 to the 5th. Now, to do these, okay, the first thing you want to do is get the bases to be the same. After you do that, set your exponents equal to each other, and then you can solve for x. So, you can see my bases are the same, 2 and 2 are the same, so x equals 5. Finish. Okay? Log base 3 of 27 equals x, so 3 to the x equals 27. So, what can I rewrite 27 as? 3 to the 3rd. So you can see my bases are the same again. Set the exponents equal. X equals 3. Moving along. 6 to the x equals 1. Anything to the what power is 1? X would have to be 0. Okay, that one you need to know by definition. Remember, anything to the 0 power other than 0 is going to be 1. Okay? Jumping down here to number 10. This is 5 to the x equals 2 over 100, because that's 200. 5 to the x equals 1 over 50. So basically, 5 to the x equals 50 to the negative 1. Now, it is impossible to write 50 as 5 squared times 2, because the bases won't all match up. So this is a calculator problem. On your calculator, you would want to hit math, and then go down to log base. Okay, so my calculator is a little bit different. right? So when I do this on mine, I'll show you here, I have a life a little more difficult than you. Because when I hit math and I go down to log base, notice it's not here. So what I have to do is I have to do this the old school way, which would be log of 0.02 divided by log of 5. Okay? Ooh, don't want to plus there. This is what you should be getting when you do it straight in your calculator. You should get negative 2.430676558. Long problem. Good news is I won't need that much space when we get over here to number 11. And 11 I'm going to put in maroon so it doesn't match. But here we go again. All right, 36 to the x equals 6 to the 1. I can rewrite 36 as 6 squared, which means I have 6 to the 2x equals 6 to the 1. Set my exponents equal, 2x equals 1, x is a half. So basically the square root of 36 is 6. Yes, okay, this works. All right, here we go with log of 4. 4 to the x equals 16 to the x. Again, we don't worry about breaking 4 down. We can rewrite 16 as 4 squared to the x, which means I have 4 to the x equals 4 to the 2x. So x equals 2x, subtract x over, x is 0. And that is that. Okay? So I'm going to pause this, shift it up. Okay. And let's wrap this up. Try to work ahead if you can. 3 to the x equals 81 to the 2x. So 3 to the x can't be broken down, but 81 is actually 3 to the 4th. So I'm going to write this as 3 to the 4th being raised to 2x. So basically, this is the following. 3 to the x equals 3 to the 8x, power to a power multiply. 4 times 2x is 8x. So we have x equals 8x. So x is equal to 0. When I divide by 7, 0 divided by 7 is 0. 2 to the x equals 32 to the x plus 8. This is where it gets interesting, okay? Because this is going to be 2 to the 5th to the x plus 8. Now, you have to think of that as in parentheses. So power to a power, that's going to be distributive property. So this is going to be 2 to 5x plus 40, which means x equals 5x plus 40. This means also if I move 5x over, I have negative 4x equals positive 40. Divide by negative 4, we're looking at negative 10. Great problem, okay? Now, finally, the last guy here. So we're looking at 5 to the x equals 25 to the x plus 3. Same idea as before. What can I rewrite 25 as? Well, I can rewrite 25 as 5 squared to the x plus 3. So think of this as in parentheses. This is 5 to the x, 5 to the 2x plus 6. So I set the exponents equal to one another, and I'm looking at x plus 6 equals 0. So x is negative 6. All right, that's your front page. I really hope you're getting in the groove here. Definitely pick up here at the back. And here we go. Okay, the following problems you're going to evaluate on the calculator. We're going to go to 3 decimal places. So as long as you know how to round and use your calculator, these are give me problems. You cannot afford to not get these correct. It's as simple as this. Pull up the calculator. Okay, turn this guy on. I'm going to clear it. I'm going to type log 0.3. Hit enter. So when I record this 3 decimal places, this will equal negative 0.523. Wunderbar. How about log of 3.5? Well, I don't know. Let's see. Log 3.5. Here we go. So we have 0.544. 3 decimal places. You got it. All right. Log of 150. And that's going to round up. So this is 2.17 or 6. Sorry, it does not round up. 3 decimal places. down to natural logs. Natural logs is right under log. It's 0.3. And here we go with natural log. So this one's negative 0.204. Remember, 3 decimal places. Natural log of 3.5. And you can see these are different values. They're not the same thing. This time we have 1.253. And last but not least, natural log of 150. 5.01 squiggle, no, 1. So that's rounded to 3 decimal places. Please don't miss those on your tests. Those are what we would call give-me problems. Do not miss out on simple problems there. Okay, final problem. If you continue this out, it's slightly going up every time. That's no good. That's what I would say we got going on there. So you can see, if I had to guess what my asymptote was here, what is the value of f to 8? I'm guessing at 8. There's no way that that's going to get up to 4 that fast. So the only thing that's really left here is I would say that this would probably get to 3 at the most. And that's where I would guess my asymptote was. So it's a growth function, so it's greater than 1. And it also has asymptote of that positive 3 mark. Okay? So, ladies and gentlemen, that was your notes for today. So if you had to be a guessing person, I would go with A. So I'm feeling Canadian with that guy. Hope you enjoyed the notes. 8.4. I do have a log and video. Just remind me to play it. And have a good night, guys. See ya.